Viscosity is the thickness, the internal flow resistance of a liquid. First, let's take a look at the model we use for scientifically determining viscosity. Here, we see an ideally viscous liquid stuck between two plates. While the lower plate stands still, the upper plate very slowly moves along, causing laminar flow. We call this the two plates model. With this essential model, we can formulate our two most important variables, shear stress and shear rate.
When the upper one of the two plates moves, it causes stress that is parallel to the liquid's surface. This is called shear stress. Shear stress wipes along the liquid's surface and stresses it that way. How to define shear stress? Shear stress is measured in force divided by area. We need to know the force that is applied to the upper lid, and we need to divide that by the area of this upper lid. Force is measured in Newton. The area is measured in square meters. Our shear stress, which is given the variable tau, is force divided by area. This calculation gives us the unit Newton per square meter, which is called Pascal. While the shear stress tau tells us how much energy is applied to the stressed material, the shear rate tells us with which speed the material is stressed. To obtain the shear rate, we need to know how fast the upper plate moves, and we need to know the distance between the two plates. Let's call this distance h. The velocity in meters per second is divided by the distance in meters. This leaves us with the unit 1 divided by second, or second to the power of -1, which is called a reciprocal second. The shear rate is given the variable gamma dot.